Hey, Matt Mathersum here with Math Madness. Thank you so much for joining us and being a part of the program today. Well, today we will be solving a three-term integration. That's what that symbol here is. And is it a definite or indefinite integration? Well, it is a indefinite integration because we have no limits, no bounds, no parameters, no guidance here. It's all a free-for-all, kind of the way we like it here sometimes. That notwithstanding, though, we still do have to solve each one of these. The nice thing is, though, there is a formula to treat these individual terms. They are terms because they are separated by plus and minus operations. And as I already said, there is a formula, but I haven't written it down this time, but we're going to do that right now. And it's just real simple. We have written this down before, though, FYI, information. And that's just x to the n dx, which is equivalent to x to the n plus 1 over n plus 1. This, my friends, will guide us to the, what do I always say, the shores of safety or something to that effect. So let's just go ahead and use that to solve for this. Well, this is x squared. So using that to solve for this, it tells us that over there, the n, which is that over here, is 2. We're just going to add plus 1 according to our formula. So let's just add plus 1 to the 2. Gives us an x3, does it not? But we also have to do the same thing to the denominator. We just bring down the 3 as well. That's our new denominator. All right. Well, we know there's an applied 1 in front of this x, do we not? Well, we do now if we did it. But you know what? We can make this look a little nicer. I just wanted to show all the operations in one full view here, if you will. But let's just kind of clean that up a little bit. I'm going to separate the x to the third because that'll just look a little nicer here. So let me just do that. So let me just put 1 over 3, and then that's going to be x to the third. All right. Now, let's deal with this 2x. We have to add this 2x. Well, we know there's an applied 1 here, do we not? So according to our formula, x being raised to the n plus 1, the n here in this case is an understood 1, and 1 plus 1 gives us, right, that gives us an x squared in our case. All right, so what do we have now? Looks like we have 2x to the second power, and we just bring down the exponent here for our new denominator, do we not? We do. All right, and I know as astute as you guys are, you're already seeing that the 2's are going to cross out, and they do. It'll give us 1, but we're going to come back to that in just a minute. Let me go ahead and solve for this right here. Well, we've got a 7 being subtracted from all of this. What's the problem with that? Well, it doesn't have an x. That's the only real problem. So what do we do in that case? Well, all we do is just add a x to it, fortunately. Now, remember earlier in the introduction when I said this is an indefinite integration because there's no, let me step over here, because there's no bounds, there's no limits here. Well, what I need to do over here in this formula actually is an add a c. That's the constant that we have to substitute when we don't have bounds. That's the constant of integration. And that c is saying that all the solutions are real numbers. That's what this says right here. C is the solution to all real numbers. What are all real numbers? That's anything except complex numbers and imaginary numbers. All right, moving right along here. We've got our formula set up here. I've got 1 over 3 x cubed plus 2x to the second being divided by 2. We said that we can have this gone. So let's just have that gone because that's a 1. We understand that. So this is just going to be x to the second. I'm just going to bring down our minus 7x here. And again, I have to add the constant of integration. I'm going to do that right here, right now. That's what that c is. And then I'm just going to bring down our 1/3 to the x cube right there. And that, my good friends, is how we do it. Well, that's all the time we have for here today on Math Madness. I am Matt Mathersum. I will see you soon.